Next problem, we're going to find the area, the graphs of the polar curves r equals 2. So r equals 2 is the circle again. So we have a circle r equals 2. And this time we do have a cardioid. That are shown in the figure to the right. Let R be the region that is inside the graph of r equals 2 and inside the graph of the cardioid. As shown in the figure, find the area. This time we don't have a choice. So remember when you are finding area, it's straight line, straight line. So I need to know where my two graphs intersect, here and here. So in problem 1, I proved it to you that they did at pi over 2. And how did I do that? I set the two r's equal to each other. So if I set r's equal, that's going to give me 2 is equal to 3 plus 2 cosine of theta. So negative 1 equals 2 cosine of theta. So negative 1/2 equals cosine of theta. And that happens at theta equals 2 pi over 3 and 4 pi over 3. So this happened at 2 pi over 3, and this happened at 4 pi over 3. So again, I'm going to do the circle first. But to do the circle, you cannot do from 2 pi over 3 to 4 pi over 3, because that's not the part that's the circle. The part that's the circle is all of this. So I'm going to do 1/2 the integral, and it has to be all in a row. So I'm going to do, this is 4 pi over 3, but it's also negative 2 pi over 3. So I'm going to do negative 2 pi over 3 to 2 pi over 3. So from negative 2 pi over 3 to 0, and then 0 to 2 pi over 3. Or remember, I could do from 0 to 2 pi over 3, multiply it by the 2 out front, and it's the same thing. So, and that's going to be 2 squared d theta. I'm going to add that to this little piece here, which is the piece of the cardioid. That is from 2 pi over 3 to 4 pi over 3, plus the integral from 2 pi over 3 to 4 pi over 3 of that cardioid, which was 3 plus 2 cosine of theta squared d theta. Now, this one is going to, when I add these two together, I am going to get 10.370. Please, again, plug it in your calculator, make sure you can do it. Lots of people think they can, and then they can't. Now, how would I do this if I didn't want to integrate the circle? So remember the previous problem where we had 1/4 of a circle? I just have to figure out how much of a circle I have here. So the other way I could have done this piece is, or, again, the area of the circle is pi r squared. So this is a circle with radius 2, so it's going to be pi times 2 squared. But I need to know what coefficient goes out front. In example, or for problem 1, it was 1/4. Well, I know this is 1/2, and 2 pi over 3 is 30 degrees. So this is 180 degrees plus 30 degrees plus 30 degrees. So 180 plus 30 is 240. So this is 240 degrees of a circle out of 360 degrees that are in a circle. So this is 2/3 of a circle. So I could have also done here 2/3 of pi r squared. So this works or this works plus the piece of the cardioid.